will have written exam on computer room. But you should read your laptop in case you cannot use a new computer to access the link. You can use your laptop. Okay? The midterm organized in computer room. But you should bring laptop with you in case you cannot access the link. You can use your laptop. So this is definition of bioinformatics. Okay, here, definition of bioinformatics. Bioinformatics that you computer and study three molecules, DNA, RNA, and protein. You don't confuse this field, computational biology. Okay, one question about definition. For the nucleotide. Nucleotide, there are three components in nucleotide: phosphate, sugar, and base. But actually, depending on components present, we will have different name. Nucleotides, that is base and sugar only. Different with nucleotide, sugar, base, and phosphate. Okay, so when you read the questions, you read carefully. It writes how many components in order to answer nucleosides or nucleotide. Sixth one, central dogma. Central dogma describes the genetic information flows from DNA to RNA to protein only one way flow. Okay? Central dogma. Flow of genetic information. DNA to RNA to protein. In the central dogma also defines template strengths and non-template strengths. Template strengths also have the other names: non-coding, anti-coding, or antisense. Non-template, coding, or sense strengths. So this slide explains in detail why the templates and the non-coding strengths had the name non-coding strength, and non-template had a coding strength. So this slide explains in detail why we name the template and non-template with different names. Slide 71 and 72 describes about the difference between exon and introns. The length and exons also have coding, non-coding region, so we classify into terminal exon and internal exons. This one, genome and transcriptome. So look at the term genome that mentions about material DNA. Genomics, studies of the DNA sequence. That is genomic, the field of study. Similar, we have the term transcriptome about mRNA. mRNA also has the other name. Transcript. Transcript. mRNA, that means gene and branch. Okay, gene and branch. Gene and branch, that means transcribe and translate, we call gene expression. Transcriptome, that mentions about focus on mRNA. Transcriptomics, study study, examine the expression level of mRNA or given cell population. So if you see this question, you need to read the statement carefully. Mention about material or mention about study. Okay, if study, you use genomics or transcriptomics depending on the statement mentioned about DNA or mRNA. Okay, that's the genome and transcriptome. Genomics or transcriptomics. Okay, that's all for lecture 1. And one thing I remind you, when you read the question, you need to identify where the question asks you to or unto. Sometimes you understand the two events, but when the question asks you unto, you don't know how to answer. Some students, when the result very close, go to see me to check the result, and I see that student understand everything, but the question asks unto, not unto. Okay? So read the question carefully. You have to bring calculator because you do some calculation. Okay, calculator. You access to Blackboard to download the sequence and also program link. When I provide link, you have to use all links. I don't give you any extra link. If you see some link you don't use, that means something wrong with you. During lectures, I explain about raw rate, linked rate, raw base, and linked base. This slide. So look at it again to calculate raw and linked base. Okay? Look at this one again. How to calculate the base, the total base, based on grid number and also grid length. And after that, we filter the poor or the low quantities. So we have the linked ones. So the linked one, you need minus the low quality base. Three formats of FASTA file. FASTA files, the header followed by sequence. Okay, the FASTA file. Very easy, but many students couldn't do this question and don't know. FASTA files. With the header follow the sequence. Okay, that's the FASTA files. Guild score. The table here, interpret the guild score. Guild 30, that means 99.9% accuracies or one error in 1000 main score. Okay, so this table show you very clear about Q score and how to interpret the Q score, the incorrect B score or accuracy percent. The question will interpret around this table. Here defines the raw data or raw rate. And then link data or link rates. Link data that means filter the organic project to remove the low quality data. Consensus sequence. This table explains about consensus sequence. The other ones, so consensus sequence, so neurotype we cannot interpret. You don't base on this one to do the design. You base on this line only. Okay? How to identify consensus sequence? I already explained. Based on the most common neurotype and that position, we call consensus. Okay? Show you the sequence and you write out consensus sequence. Where neurotype the same characteristics, where neurotype difference, for example, T and C here. C more common, so that's why consensus C, not T. Okay, you don't integrate into R or N something like this. No. Okay, based on this one already. That lecture 2. Database. Database, this line explain primary database. And then secondary database. And then example of secondary database. Here, example of secondary database with prompts. The key thing you have to remember. Secondary also originator libraries, but more information we call curated. Okay? Secondary database originator libraries and add more information we call curated. That are different between primary and secondary database, and one program you perform UniProt. UniProt during lecture I already explained for the UniProt. you run this one again, okay, and you run uniform again to see, for example, each one. Okay, reviews, popular organism, in entries, when you access to entries, some information about entries, protein name and gene name, different understand. You look at, depend on the question asked you, protein name or gene name. Another one's organism, actual scientific name or common name. You don't remark joke. Because you remark joke, that means you don't understand anything. I check what you understand. If I ask scientific name, the one outside the bracket. If I ask you common name, the name inside the bracket. Okay? If you revoke correct to 0, because you cannot identify which one scientific name, which one common name. And also look down the publication. Based on the category, cellular component of molecular function or biological process, depends on the question asked you which categories. That's all for lecture 3. Lecture 4. One question asks you about work size. Work size for nucleotides different with work size for protein. Okay, you should remember the work size for nucleotide, the number 11. For the proteins, 5. So that means the work size for DNA large compared with work size for protein small. Okay, sometimes the question not mention correct 5 or 11s, but just remember protein small number, DNA large number, because the multiple choice will change the number. Matrix. This table interpret the part matrix. The subject number. Okay? The subject number here show you the observed difference 50% and the part number part 80. 80 here not represent 4% difference. Okay, just remember that. 80 and 250. If high number, that means show more difference or more similarity. For the part, higher number show more different. Okay, that opposite with the blossom. Blossom also has a separate number here. And high number show more similarity. That's the blossom. Okay, blossom and palm, the number follow different in further palm, more different or divergent. Compared with blossom, more similarity, the high number, the high number. And then you study raw score and big score. Big score that normalized score. Okay, normalized score we got big score. Raw score. Just based on matching, mismatch. That's the raw score. Gap, something like that. And then we have one slide explain about evaluations. 72 and 74 explain about evaluation. In the key thing for this lecture class, during lecture, I explain very detailed how you can design the correct class. Class P, class N, X, and T, class N, depend on the question. You receive the sequence, you look at the sequence DNA of protein first. And after that, the question asks you DNA of protein, and then you can design the correct class. You already finished assignment for this one. Many groups got high score, even 100 points, but some group only around 50 points. So that means you perform wrong class, and again, for me to decide. You do by yourself. You cannot do it for your group. Now you look at this one again. How to design correct class? Okay, when you receive sequence, and the person will not tell you which class you perform. Okay, the same with the assignment. You have to decide. If you decide the correct class, you get the right output. Otherwise, you get 0 for the whole class. And the whole class, I check how many points. 10 points. If you design wrong class, you lose 10 points. So that means when you perform class, very important to design the correct one. You receive DNA and ask you about G, about DNA, black N. If you receive protein, ask you about proteins, black pink. That's right. If you receive DNA and ask you about proteins, so that means black X. If you receive protein sequence, ask you about gene, T black N. Okay, just follow that simple principle. You can decide correct class. I perform one class. Chapter 5, the class. If the question asks you about the query sequence, you look at here, the query sequence. Okay, the query sequence you look at here, the length, the molecules. When you report the length, you always report together with the unit. If the DNA you have to report 941 base pair. Molecule type, DNA or protein. And don't know when you did assignment, many look wrong with molecule type and report the length with the unit. You cannot get full points for that. Okay, you have to report and repeat many times. When you report the length, you have to report unit together with the number. Base pair or amino acids depend on DNA or protein. Okay, we don't have unit nucleotide. Base pair, not nucleotide. Alright? So report 941 nucleotide incorrect. You have to report 941 amino acids, and after that, if the report asks you the back hits, that means you pick up the first one, okay, and you will look at the alignment here, results, and also information of that sequence. Click that section that brings you to the information that it match with your sequence. That's the part. We move to lecture 5. Why do we need to align sequence? That is objective of the sequence alignment. Slide 4, 5, and 6. That objective of sequence alignment. Orthogonal paradox. In example 21, 22, 23 is about orthogonal and paradox. How do you define orthogonal and paradox? Orthogonal in different species. Paradox within a single species. Okay, that's the definitions of orthogonal and paradox. The calculates identity and similarity. Okay, in this calculation, you need to identify the correct length. Length includes the gap. Remember that. And the question will be very clear about match, mismatch. Okay? Another calculations. Also, scoring system. In case, we will define how to score match, mismatch, gap open, and gap extend. Okay, gap open and gap extend. During lecture, I already explained very detailed. screen or something like that, where which slide number? Here, handmean distance. How to identify or calculate handmean distance this slide? The local sequence alignment, slide 50 and 51, explain about local sequence alignment. That lecture 5. Lecture 6. Assembly, slide 5, 6, 8, explain about the novel assembly. Calculate and 50. Slide 19 and 20. Actually, not calculate, identify which ones, 9, 50. Okay, just based on the principle, very simple. And you just finish gene revision. Gene revisions with ab initio across. Ab initio across, that means without any informations. And this slide shows you some difficult when we apply this ab initio across on methods. Slide 46. 59. 68. These ones show you some difficulties when you apply ab initio repetition. Again, these ones identify open reading frame. Open reading frame finder. You run this program again. There's this programs. You have 6 ports for this program. And after that, you pick up the correct sequence, perform blast again. And you have to identify the correct open reading frame to perform blast. Here, define about transcription unit in prokaryote. Transcription unit may contain 1 promoter plus 1 gene or 1 promoter plus a number of genes. And this one shows you the order of study of genome based on NGS. Okay, based on NGS. Slide number 4. Here. Sequences. Quality check. Trimming. Assembly. After assembly, assessment. Quality assessment. First go. Annotation. Just remember the order. Which one first? Step 1, 2, 3, 4, 5. Because I will change the order and I ask you identify the correct order of the start date to the start date. Okay? Because I change the step. Which step first? You have to know. Sequence first. So this slide shows you the orders of genome style, genome assembly and application. Again, the guidance, you have to read the question carefully after you do or learn to. Now those on sequence and program link, when you access to computer, and you go to the blackboard to download sequence and program link. Bring calculator. Before COVID, I never organized review session. Student also could do exam. After COVID, I organized session, this session, review session. But I don't know, many students couldn't do this. I already aimed for some quick question I asked you exactly the same. But I don't know, students couldn't do the same. Okay, so that means your fault, not my fault. Any question for Peter? Any question? 19 minutes open book exam. You can read everything with you. Exam, laptop. Okay, you take note. Directly on the slide, you have to read it. You cannot open laptop to look at slide. Only when you have set to the computer, you do assignment, you do path to computer base. And you cannot access to the link. You can open laptop, but you cannot open laptop to look at slide. You cannot. Okay? You remember, you take note, you have to print it out. And you can bring that material to the exam room. Any question about? If no question, good luck for the exam. You also have assignment to do. Okay, we'll open when we finish lecture today. You should do exam, the assignment. And I asked you something before with the exam because some questions similar to that.